At the Carnegie Mellon, we are developing low-density multifunctional materials which have a broad range of applications in aerospace, automotive, and biomedical technologies. For example, in aerospace application, we always want to use less materials so we can reduce the payload for space shuttles. You can imagine if we have one material simultaneously realize multiple functions, so we can significantly reduce the usage of materials and therefore the cost. So here, we choose polymers as a general material platform to develop those multifunctional materials. So because the polymers are low density, low cost, easily processable, and electrically insulating. As we all know, polymer usually exhibit low stiffness, low strength, and low thermal conductivity. So this is because polymers are often amorphous with randomly coiled polymer molecules. And also they have defects such as voids and also molecule entanglements. So a big challenge for us is how we can develop a polymer which are thermally conductive and ultra strong. In fact, this is fairly possible for us. Just as a spider can synthesize a silk from protein polymers to form a fiber with a strength comparable with steel, polymers can be spun and drawn to form ultra-strong materials with exceptionally high thermal conductivity. So we can engineer those molecules to make them highly aligned, oriented, and those defects can be significantly eliminated. I want to highlight these purely nanotechnologies. The polymer nanofibers we developed usually have diameter around 10 to 100 nanometer. They are quite tiny. So by leveraging those nanoscale effects, use polymer nanofibers, we have achieved very high thermal conductivity in polymers, which is around 100 watts per meter per Kelvin. So this value is better than most metals. We also demonstrate those polymer nanofibers can have very high Young's modulus and strength. The Young's modulus can be as large as 300 gigapascal. The strength can be as large as 12 gigapascal. So those values actually around 300 times larger than those for bulk polymers. So the polymer nanofibers with lightweight, mechanical, and thermal multifunctionalities can find common applications in many fields. Let me give you a few examples. So those polymer nanofibers can be used as lightweight and conformal reinforcement in civil engineering structures. Also in biomedical devices, those wearable and portable devices, as well as robotics. The results we have demonstrated so far works in the single fiber level. Currently, at the Carnegie Mellon, we're also developing an innovative manufacturing approach to scale up and mass produce those polymer nanofibers. We really believe this is a game-changing technology by transforming polymers from soft and thermal insulating materials to ultra-strong and thermally conductive material.